All right, so the idea with the domain is that we want to put a real number into our function, do the little function notation, get something out that is real. So we want to put in a real input, get a real output out. So something that's going to be not real, of course, is if you get an undefined, that is not going to be a real number. So the two issues when you talk about the domain are an undefined, which is caused by when the denominator is equal to 0. That's one issue. And then the other issue is going to be if we get an imaginary number I, because imaginary numbers, of course, are not real numbers. So the imaginary number I is caused when we have a square root of a negative number. So when we're talking about the domain, we're really focusing on, do we have a denominator that is equal to 0? Is there an issue for that? Excuse me. And then do we have an imaginary number coming from a negative underneath the radical? So if you look at a question like number 75, in number 75, we have a rational function, 3x squared divided by x squared plus 9x minus 36. So when we're looking for the domain here, we don't have a square root, so we're just focused on the denominator. And we want to make sure that this denominator is not equal to 0, because if it was equal to 0, we would have an undefined, and that would mean that we would not get a real output out. So I always think about the D in domain, D in denominator. We're trying to prevent an undefined number, so we have to make sure that the denominator is not equal to 0. Now, to answer this question, I would just kind of think about it as an equation, and then at the end put the not equal to part in there. So if I was solving it as an equation, the first thing that I would notice is that I have a second power. And when we have a second power, we have a quadratic equation. So we have all of our different methods for quadratic equations. We have factoring, quadratic formula, and so on. So I'm going to start off by trying to factor it. So to factor, I would think about the factors of the first times the last. So factors of 1 times negative 36. So we need two numbers that multiply together to give us negative 36. And they need to sum up to give us positive 9. So you might have to work to get to this, but eventually you're going to see that if you have a positive 12 and a negative 3, those multiply together, give you the negative 36, and those added together will give you the positive 9. Now, this question is nice because we have a 1x squared. And anytime you have a 1x squared for the polynomial, you don't have to split up this middle term in order to factor it. You can just write it as x and x, and then write down that winning combination that you found, in this case the 12 and negative 3. So what we would do here is once we get our 12, negative 3 winning combination, we would say that x squared plus 9x minus 36 is equal to 0. We'll factor to x plus 12 and x minus 3 equal to 0. And now we can set each of those factors equal to 0. We get x plus 12 equal to 0, x minus 3 equal to 0. That gives us x is equal to negative 12, and x is equal to positive 3. Now remember, those are the numbers that cause the denominator to be equal to 0 and give us an undefined. So we do not want this number, we do not want this number. And so that's the reason why when you look at the answer choices, they have the step builder notation, they have x bar, and then x cannot be equal to negative 12, x cannot be equal to 3, because those are the two numbers that will cause a 0 in the denominator. So again, the key takeaway here is we're setting our denominator not equal to 0. Sometimes that involves factoring if we have a quadratic, and those numbers are the numbers that are what we call the domain restriction for that rational function.